Okay, hi. In this video I'm going to explain the difference between a secant and a tangent and how the tangent is derived from the secant. So to begin with, a secant shows the average rate of change of a function, and it is basically a line that goes through 2 points on a curve. The slope of this line is the change in y over the change in x, and from here to here would be delta y, and from this point here to this point here would be delta x. And the slope of the secant, which is the average rate of change between those 2 points, is delta y over delta x. Now the tangent shows the instantaneous rate of function. So the slope of this tangent would show the rate of change right at that point there, and we can find the slope of the tangent using the slope of a secant. So this line that goes through the curve is a secant. Okay, the slope of the secant would show the average rate of change between the 2 points here and here. But let's say we want to find the slope of a tangent right here at this point here, so the instantaneous rate of change. To do that, we would have to shorten delta x. So here delta x is smaller, but it still goes through 2 points, so it is still a secant. Okay, here as you can see, the secant is gradually approaching the tangent. As delta x keeps getting smaller, it starts to look more and more like a tangent, but this still goes through 2 points, so this is still a secant. Okay, this is a tangent. Delta x is infinitely small. It is very close to 0. It hits the graph at one point and then is tangent from there. So using that concept, we can now find the slope of a tangent. So using the slope of a secant and this graph here, we know that the slope of a secant is delta y over delta x, which in this case is f of x plus h minus f of x, that's delta y, and delta x is h. So the slope of the secant is f of x plus h minus f of x all over h. So using the concept that we just saw, we can now find the slope of a tangent, which is the limit of the slope of the secant as the change in x, which in this case is h, goes to 0. So the slope of a tangent is the limit as h goes to 0 of f of x plus h minus f of x all over h. Okay, so an example. Suppose f of x is equal to 3x squared. Find the slope of the secant line that passes through the 2 points whose x coordinates are x equals 1 and 4. So the slope of the secant is equal to the change in y over the change in x. And here that is equal to f of 4 minus f of 1 all over 4 minus 1. Now we plug 4 and 1 into the function, which is 3x squared. So the slope of the secant is equal to 3 times 4 squared minus 3 times 1 squared all over 3. And this is equal to 45 over 3. And this is equal to 15. Okay, so graphically what this means, here's a graph of 3x squared, and here are the 2 points, x equals 1 and x equals 4, x equals 1 and x equals 4, and here is f of 1 and here is f of 4, and the slope of the line that goes through those 2 points is 15. So that's the average rate of change between 1 and 4. So to recap, a secant shows the average rate of change of a function. It goes through 2 points on a curve, and the slope of the secant is the change in y over the change in x. And the tangent shows the instantaneous rate of change. It goes through 1 point on a curve, and the slope of the tangent is the limit as h goes to 0 of f of x plus h minus f of x all over h.